I'm Anil Kumar. Here is another question on polynomial functions, and I hope that will help you to review the concepts. The question here is, describe end behavior of the following polynomials. We have four polynomial functions here. First one is y equals to minus 2x cubed. B is y equals to x to the power 4 minus x cubed. C, y equals to x to the power 5 plus x squared minus x. D is y equals to 5 minus 3x squared plus x. You need to write end behavior of these functions. You can always pause the video, answer the question, and then look into my suggestions. So let's try to understand what is end behavior first. What is end behavior? If you want to write end behavior of a function, we could, especially if it is a polynomial function, we could analyze two things. One is the leading coefficient, the other one is the degree, right? Leading coefficient and degree. These two things help us to find end behavior. But the basic question is, what is end behavior? End behavior really means that if x approaches a large negative value, what happens to y? Or if x approaches a positive large value, say positive infinity, what happens to y? That is the end behaviors, right? So let me do the very first one. Y equals to minus 2x cubed. So if I sketch a graph, which is not a must, minus 2x cubed, leading coefficient is negative. If the leading coefficient is negative for a polynomial, right side is towards down. If the degree is odd, both are opposite ends, right? So it's kind of like this. So for a cubic function, the graph could be kind of like this. Do you see that? So we get a function like this. As you can see, that as x value approaches negative infinity, that is, if x approaches negative infinity, y approaches positive infinity. Do you see that? And if x approaches positive infinity, that means right side, y approaches negative infinity. Do you see that? So that is the end behavior. That is how you describe end behavior. So what happens to the graph of the function as x approaches negative infinity? And what happens to the graph of the function when x approaches positive infinity? End behavior, the two ends of the graph. You could also describe this by saying that the graph goes from quadrant 2 to quadrant 4, right? You could also say that the graph, I'll write it down. We could say graph extends from quadrant, let me write in short, quadrant 2 to quadrant 4. So that's another way of describing the end behavior, right? So you got the concept. To describe end behavior for all these functions, you have to check leading coefficient and the degree. If the leading coefficient is negative, as it is in this case, the right side is down for the graph, or degree means opposite ends, right? Let me take another example here. Part B, y equals to x to the power 4 minus x cubed. Now what is the leading coefficient? Well, the leading term is x to the power 4, leading coefficient is positive, right? So we'll kind of sketch this graph, only the end behavior. Positive means right side up, and since the degree is even, both sides are up. Is it okay? Both sides are up. So I could always write the end behavior as when x approaches negative infinity, y approaches positive infinity. And when x approaches positive infinity, y approaches positive infinity. So in both the cases, as the x approaches both limits, the graph of the curve approaches positive infinity upwards. Is it okay? Since degree is even, that is why. Both are on the same side. Positive means right side up, right? That's what it means. Or you could also say that the graph extends from we can say now from quadrant 2 to quadrant 1, correct? Right. Some of you can actually factor and make accurate graph also. Well, I can take x cube common. So we got x minus 1. So we'll not do the same for the other two, just to give you an idea how the concept works, right? X cube means 0 at 0, x minus means 0 at 1. This is linear, this is cubic. So the graph could be kind of like this. Now let me extend this. Do you see? Now I hope that you have understood the term and behavior, and you can answer part C and D. Part C is y equals to x to the power 5 plus x square minus x, and D is y equals to 5 minus 3x square plus x. You can pause the video, answer the question, and then look into my suggestions. Now, as we have done the previous two, we'll actually analyze by finding the leading coefficient. So the leading coefficient for us is what? Leading coefficient is positive 1, right? How about the degree? Degree in this case is 5, which is odd. Is it okay? So if the leading coefficient is positive, that means what? Let me kind of make a rough sketch only for the end behavior. Leading coefficient positive means right side up. Odd means opposite ends. Do you see that? And therefore, we could write the answer as when x approaches negative infinity, y approaches negative infinity. And when x approaches positive infinity, y approaches positive infinity. Perfect. Now the last one for you. Y equals to 5 minus 3x squared plus x. Now what is the leading coefficient? Well, the term minus 3x squared is the leading term. Remember that, right? So that means an, the leading coefficient is negative, right? And degree is even, right? So both are on the same side. Negative means right side down, both down, correct? And therefore, for this, we can write when x approaches negative infinity, y approaches negative infinity, and when x approaches positive infinity, y approaches negative infinity. So, well, this one is from quadrant 3 to quadrant 4, and the previous one is from quadrant 3 to quadrant 1, correct? So you could also describe in terms of quadrant as we did. So to summarize, if you have to write end behavior of a polynomial function, you need to analyze leading coefficient and the degree. If leading coefficient is positive, graph ends in quadrant 1. If leading coefficient is negative, it ends in quadrant 4. If the degree is odd, both are on the opposite ends. And if the degree is even, both are on the same ends. So that helps us to describe the end behavior. I'm Anil Kumar, and I hope you appreciate it. You can always share my videos with your friends and subscribe. Thank you, and all the best.